Test, test, test. Test.
go start at the clams and work our way to the depth.
That's right.
Okay.
All right, hello everyone. Welcome from the RV Falkor. I'm Victoria Orphan, and we are part of the Leg 3 science team studying the biology, microbiology, and geochemistry of this amazing hydrothermal vent field in the South Pescadero Basin. And today's dive, we are going to be starting at a place that it was a newly discovered hydrothermal vent field that was visited on Leg 2, so maybe some of you have seen it before, but it's called JaichMaa, and that translates to liquid metal in the Killua language. And these are native peoples of the Baja Peninsula in the northern part of Baja. And many of the sites that we've named in this area are based on the Killua language, so we're trying to keep this ancient language and honor the people here by picking appropriate names for these sites. So the Auka field was one that was initially discovered, and the JaichMaa was a field that was discovered in 2018, which was the last time we were here with the RV Falkor. So we are going to be diving at one of the spectacular features in the JaichMaa vent field called the Big Cavern, called Tay Ujaa. And we're going to start with some sampling on the outskirts, looking at the sediments that are colonized by chemosynthetic clams. So these are clams that have sulfur oxidizing bacteria in their gills, and they're using that hydrogen sulfide that's emitted either from underlying vent fluids that's ejecting to the seabed, or possibly from sulfate reduction by microorganisms that are living in the sediments. And that's one of the things that we were trying to test right now. So the Leg 2 team was out here doing heat flow measurements and noticed that the heat flow, or the gradients of temperature, were a little warmer in places where we found dense clam communities relative to the surrounding areas. And so now we have the opportunity to get a little more data for them and try to put the context of the geochemistry and the microbiology alongside the expressions of chemosynthetic activity on the seafloor, looking at these clam beds and microbial mats. So we'll start with that kind of push core sampling, and near the end of the dive we'll head over to the Big Cavern and sample some of the mineral formations there and animals. We look forward to giving you a guided tour.
Do you have the basket map filled out for the pelagics?
I don't. I can. Yeah.
Was it 1 and 2? That have been done?
Yeah. I think.
Yes. 1
Yep.
and 2. Cool, cool.
It's not a swimmer.
It's not a swimmer. It's a big morning. It is. We call that snot.
It's not seem to held together against.
No.
It's not funny now.
It's not. It's not the time. Sorry, do you remember your depth?
1450.
Yeah.
Oh, microbial lens. Oh, microbial lens.
feel like you found a mystery one.
Greg's gonna have to Scooby-Doo that one.
Right, you guys can see on the screen in the inlay here is the bathymetric maps that were generated. So the larger scale maps that were done by the RV Falkor driving along different tracks. And then the inner map that's at much higher resolution that was created by the team at Mbari, led by Dave Caress and Jenny Padwan. That is at sort of the meter to 5 centimeter scale data done by AUV mapping.
I'll just go for my coffee and I'm ready.
Indeed, this has been a labor of love. A lot of hours of mapping have gone into creating these really detailed maps of the seafloor bathymetry that are really critical for us, not only in identifying new expressions of hydrothermal activity that can be explored with the ROV, but also giving us the general context of the geology and how these basins form. And this has been some outstanding questions that our collaborators on Lake 1 and 2 have been interested in trying to answer this whole Gulf of California genesis environment. And so you can see now we're coming up on the higher resolution maps that were created by the autonomous underwater vehicles, these AUV mapping systems, and they are represent many days of mapping, and so it gives you just the general context of the different spatial scales and just how much time and labor has gone into generating these critical maps that help inform all of our science. So John, is it possible to like outline one night's mapping or highlight something like that, like the one little swath that we did the other night?
Not now.
Yeah.
We can pull in a 24-hour section from Lake 1.
Yeah.
Just kind of have that sort of thing.
Yeah.
I wish I had brakes like you.
Those have good brakes.
at the bottom.
32?
I mean the amphibolic. Shouldn't he be on the
Yeah,
bottom?
nobody told him. He's,
Maybe those are the ones that hitch rides on jellies.
yeah. Yeah.
Cool.
Well, also the sea cucumber, Greg was thinking was awfully high in the.
Did you see another one up in the water column?
Uh-huh.
Really high? Oh, the dead one did on earlier.
I thought it was a pelagic cucumber, but he's,
Yeah.
he's not sure.
Greg was looking to see if there was
Dead as a
sediment on
hammer.
it.
Yeah, I saw one that really looked like a bottom one, way up high on leg two,
Yeah.
and he was swimming up,
That's a long way to go.
or they were swimming up. I don't know what cucumbers are.
Separate sexes.
Okay.
Always good to check. So many animals are hermaphrodites.
Are they visually distinct on this? Without?
I don't think
on a
so.
green?
I think gonads
Yeah.
have to be
Yeah.
observed.
Okay.
Dragging and
He's got it.
all around.
It's amazing.
It's cool.
Yeah.
Dragging a little snowball.
Yeah. It's like lunch for the week.
It's foraging on it.
Yeah.
Wild.
That's
That's
very
amazing.
cool.
Weird.
Oh.
Oh, he wants the
Aw.
ball. We'll go back for it.
It's like a squirrel with a net.
Oh, he's going back for it. Go back for
Get
it.
it, get it.
Oh.
Oh.
Go get it, Rock. Go
Go get it. Go get it.
You just,
I got to that's just lunch bag.
Oh, let's go. Oh.
right, so you can now see from the bathymetry the,
Yeah.
the expressions of these
Yeah.
different individual events within these hydrothermal fields in the southern Pescadero Basin. So So a few days ago, we were able to dive on another feature that looked really similar to these, that was sort of midway between the Alka vent field and the JaichMaa Yag fields, that because of its shape and location in this sort of linear fashion going north to south, was predicted to also be one of these hydrothermal vents, and so we were able to dive on it with the ROV, and indeed it was a spectacular vent site. And so there's a couple of other areas that are even further to the south that we're going to also try to explore on a future dive, and see if they also represent active areas of hydrothermal venting.
Don't worry about the light.
Oh yeah, I think it's a serrate octopus.
Ah, okay. I just got to this.
Yeah, and then here I'm on magic.
Great, so there's a vampire tooth
I
squid.
don't think so.
No.
We got this wrong last time.
Yeah, I think it's an octopus.
Greg and I
It's hard
actually
to
were.
tell though, because it didn't
He didn't
unfurl
unfurl.
his arms.
Yeah.
Yeah, we had this debate last time we were out here too.
Yeah.
And we were. The geophysicists were correct. Can you believe it?
I travel with the octopus lady on occasion. We've been to see a few
Janet?
times. Yeah.
She would know.
She chimed in after the
Oh,
fact.
did she say it was a
After the
serrate?
fact.
Yeah, and the people in Bari also told us, and we're like, okay.
We're going to change the whiteboard.
Yes, for sure. Let's get it up to date. You'll do C-Log, I'll do notes. Yeah. Yeah.
So it's going to be like where when it's. It's like this. When you don't have to switch it, no, porque vai.
Oh, that's like Yoda. So, because I'll send you that goes on the regulation. Things before, but just know that do it when this will go up 5 on the line straight away.
Yes, I know.
What's that? You know, like,
It's a J.
followed by that, so you will, it's a little bit more comfortable. And what they do, blah, 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 blah.
Yes.
So,
Well, we have like
they call it a title.
at 10, not 9.
Yeah, yeah.
Well, you got something 9:30.
No, 10:30 for sure.
On the calendar, it says 9:30.
Which time's that? That's not that.
I'm looking at the screen that's in blue.
That may not have been adjusted. Yeah.
Down in the S.
Because Hannah didn't send me that invitation, so I'm not sure.
Yeah, I've got 10:30 on all of these. I suppose with the middle school, if they are aware of what's going on.
Yeah, 12:30, 2:30 right here.
It's Slack, yeah, they double check.
Just working through some logistics over here. Audio's working.
Look at all those push cars right in the middle.
I know, isn't it a beautiful sight?
Beautiful.
Yes. We did a little reconfiguration of the ROV basket last night. We say we, it's the royal we, actually the amazing pilots did this. So late in the evening.
And early this morning.
And early this morning, yep. They're very dedicated to trying to help us do the best science as possible. So we removed the water samplers that we use to get pristine samples of the hydrothermal fluids at some of these sites, and now sort of optimize the location of the push cores and the temperature probe to try to better enable our science in a more efficient way when we're on the seafloor.
Those are some awesome legs.
That is a beauty.
Thank you.
Jared's got nice legs too. Huh?
Just not growing in the edge. For help. Should this in? Oh, there you go.
Hmm?
Oh, I sensed you now. They have the cutest little paddle feet.
Yep.
I know her well. She's star. It's great that she's working a day so much.
Yeah, well, they just come out here.
Yeah.
That's great.
Yeah. Yeah. They lost audio in Victoria. They're doing something.
It's like I turned it off so we can.
No, I know, but it looks like there's a.
No.
Launch into a big story. Nobody heard it. Aw, that's a good story. Happened to me the other day. They're like, nobody heard you. I was talking to myself in here.
Yeah. All right. We're at 3660. We should be reaching the seafloor momentarily. And there it is.
Seafloor?
Seafloor.
Seafloor.
Ah,
I see.
okay. Wonderful. So we are landing a little bit southwest of Tay Ujaa, which means the Big Cavern in Killawah, which is a native language of some of the indigenous people of the Baja Peninsula up in northern Baja. And for those of you who have not had a chance to see the Big Cavern, you're in for a treat today. It's a really spectacular feature. And this hydrothermal vent system itself was named also after an expression within this cavern, which is this beautiful underwater lake, this pooling mirror-like finish of hydrothermal fluid that is collecting in that cavern. So this vent site is named JaichMaa, which means liquid metal. And if we get a chance to see this a little later in the dive, you'll see why we selected that name.
I don't think we're starting at the cave.
No, I said we're starting down here.
Yeah, exactly.
Yep.
And eventually working our way up to it.
Because we thought if we got to the cave,
Gotta-
we would just ooh and ah all day long.
That's
very
right.
true.
That's right.
Stay in
That's
the mud
right.
for a little bit.
So we're right on the edge. I would turn the drive about 160 slowly. We should
Okay.
come across
Right where you're at.
the map.
All right, so Ben, we're gonna cruise at a heading of 160,
Once we get to the
and
seafloor.
once we can see the seafloor again.
And
we're looking-
searching for a mat and a rock that I will recognize if we see it. And the dam's very good right now.
So just so you guys are on the same page, this is the adjusting JaichMaa geotiff.
Thank you.
The pilot, the co-pilot would work without us restarting Green Sea. And we can result from markers and everything. So we're just going blind on that. And
Yeah.
then the flight of us is not adjusted because we just have the geotiff, not the 3D point cloud on it. So that's the one to go by. And then
This
we can
one
use
here?
it. Yeah.
Okay.
And it's like 2 meters plus or minus that Dave managed to get to.
So y'all want to start with the clams and then just kind of
We're
creep up north?
we're looking for the microbial mat patch that we sampled in 2018. Should be off in this direction.
See on the map for Victoria. It's 160. Just trying to.
Yeah, yeah.
Can we see the flange?
Yeah, okay, so it's a bunch of,
These are the hot features.
yep.
We should have seen the flange yet without a offset.
Yeah,
The
we
upside
haven't
down
seen-
flange.
Yeah, of course, it's only a meter across.
Yeah,
It's
okay.
Pretty small feet, so. Yeah, looks like we're south of that. We're gonna run into the other man, so we keep going this way, but about the one we're landed on, which is okay. I think.
Should we turn, go east?
Yeah, we've gone past where that first mat is, but we're heading for where the other mats are. Although,
But
yeah,
I
we
think we
should
wanna
turn
be-
her east because the other mat's gonna be a little east of us, I think. Yeah.
I think we
So
want to go
let's
to
just
the,
do a loop around the east and come back to the launch point.
Turn east.
Yeah, we're seeing the edge of that mound right there.
But that's-
It's got
Carl, is
mat
that our
coming off
dive
of
site
it.
right there?
we want to go to the ones we sampled before, not just any,
If we-
right?
Right, I think so. I
Yeah,
think so. So,
Victoria,
yep.
It's a small
look at the
chart.
map above Carl. That also is kind of helpful.
but it's
That
not.
one is not.
It's not, it's
Yeah,
not
that's
shifted.
But there's some
I think they were saying this
Yeah,
one is the
okay.
one that would go up.
That one's gonna stay
Yeah, see,
static.
there's a reflector of that mound right there, and it's got mats
Yeah.
around it.
Yeah.
Yeah, so these points, these are our points.
Yeah.
These are offset.
And they should go that way about,
Yeah, so they should be
30
Would you say here?
yeah.
So there's the two spire type
Right.
features, and then there's a mound to the south.
Right, we can
Check out
barely,
the
East of
sonar.
them.
Check out the sonar.
Yeah, here it
And
comes.
we
Yeah.
want to go.
yeah, we're coming up
Here we
on
go.
it.
Yeah. Well, but these are
It's different ones.
different. If we're
Yeah.
looking 120, we're looking at this feature,
Right, the
Yeah.
big
and we
one
want to be
we-
up here.
Yeah.
Yeah. See, it's got mats surrounding it, but yeah, we'll just work our way back.
We want to be at this little guy over here.
Follow that friend of the mats, and she takes them to the other man.
Yeah.
Yes.
Not any map.
Yeah, but this.
Well, it's good. It's good
this
to
is a-
survey because this
Yeah.
is another possible
Exactly.
place we
This
could
is
come.
certainly a horrible place here.
Yeah.
So.
Yeah.
I mean, we could take temperature probe measurements here and see if it's.
Yeah.
So, before we head further north, why don't we settle and we could take some temperature probe measurements here, and if they.
Just anywhere here. Just on map to the
Well,
map.
at the map, yeah. Be good to get that data anyways, and then we
Yeah.
can,
Yeah, this is nice and isolated. Should be good.
Yes, there's good.
Any particular area here? Preference?
definitely
Somewhere to the
not
left?
not a rocky area. Let's look and see if we see any evidence of hydrothermal activity.
Yeah, let's go sit on the other side of
I
that
think that's-
map, where it's a little softer, maybe a little cooler. This
That's
looks very-
definitely
ooh, that's
shimmering
very
there.
hot over there too.
And there's some coming out right there.
Yeah, you know what? We're gonna peg the probe if we probe it here.
No, I'm thinking I'm thinking my.
Oh, your probe.
Yeah,
I'm
yeah,
sorry.
not the heat
I
flow.
thought you were
Yeah,
doing
yeah.
clam.
No, no.
Oh no, yeah, this is perfect. Sorry,
Yeah,
my mistake.
yeah.
The virus control, Victoria?
Yeah, I do. Hopefully. Yep, I do. Yeah, so there's some nice flow coming out here.
Yeah, oh yeah.
A few different spots.
Yeah,
Okay.
Oh, yeah.
that's nice.
This is looking promising.
Are you happy with this area?
I am happy with this
Say
area.
again?
Let's see if we can
No, we're southwest.
line up.
So
So
that's
we're gonna want to.
big structure.
There's a few different types of mat that we're seeing here. So there's the whitish and there's this gray, and then there's a bright white that has the hydrothermal flow. We want to see if we can probe with the temperature probe in each of those. So however you want to line yourself up.
No name, no.
What's that?
It's a little bit of an incline.
Will you be able to push the basket out for sampling?
Push the mask down. It's
Yeah.
really hot.
I guess don't sit on the hydrothermal feature. Yep. So all of the white and kind of peachy colored stuff you see on the ground is microbial mat. So these are bacteria that are chemosynthetic, likely using hydrogen sulfide. It's coming, infecting up from below, either from the hydrothermal fluids themselves or possibly generated by other microorganisms that live in the sediments, organisms that are known as sulfate reducers that can use sulfate in seawater, which is quite abundant at 28 millimolar, and that sulfate diffuses into the sediments and then serves as an oxidant for anaerobic bacteria that can either couple it with organic carbon oxidation or possibly using inorganic sources like hydrogen coupled to sulfate to fix carbon dioxide. So all of these metabolisms are occurring just beneath the seabed, and this is why we use these sediment cores to be able to probe down to about 20 to 25 centimeters below the surface to look at the gradients of microbial communities and the different kinds of geochemical processes that they're engaging in.
took the house out.
Yeah, we could put the house there. We were thinking about on the.
Sure, we'll come back after.
Yeah. All right. Let's get a little lay of the land here.
Okay.
I think this could be the south side of the maps that we're looking for.
Yeah.
That yeah, I think we're basically right.
It's actually flow right underneath us.
I can see it, yeah. Okay. Question is, how do I tell you?
Well, there's an anemone right in there.
Yeah. Extreme anemones.
Brave.
Wow.
Beautiful.
Sort of where the chords were last time.
All right, so we see one, looks like a lone Oasisia tube worm and a number of white anemones and some scale worms,
They're
Phenolae
really
polynoe.
covered in bacteria, the scale worms.
Scale worms are definitely a little, hairy. And one of the scientists on board discovered last time with samples that were collected from these environments that these anemones actually have symbionts living in their tentacles that allow them to use hydrogen sulfide as a new kind of symbiosis that was not previously recognized, but it helps explain the dense numbers of these anemones in these environments.
Yeah.
What's that?
We're just looking at some
Okay.
of the old stuff.
So there's some paraalveolids
Yeah.
right there, and some copepods.
We're hoping to get the other species today.
You want to try to?
I mean,
There's some
eventually. Yeah,
amazing.
I think before you move on, we might want to slurp those guys right there,
Yeah.
foreground, and the copepods, of course.
Okay. So let's start with the temperature probes. Let's pull that out. Hopefully we'll get your.
Can I take over the camera?
Yes, you can. So Florian, I suspect that the main driver here is the types and abundance of different reductants and oxidants that microbes use to generate energy, and then secondarily temperature. Additionally, is a controlling factor in terms of sort of setting the limits of which types of organisms can grow. So when you start to get to these higher temperature regimes that we've been measuring, and these are organisms that are known as thermophiles or hyperthermophiles, organisms that are adapted to life at high temperatures. So this would preclude some of the other organisms that might normally be able to use that chemical energy but cannot because of the extreme temperatures. So each of these different components, the chemistry and the physical environment, help shape the types of microbes that occur in these habitats.
It's all yours.
All right, so let's go straight into the orifice there.
Should give a shout out to Florian, our heat flow guy.
Yeah.
Part of Lake 2.
Yes. Hello, Florian.
It does. I agree. Yeah.
Okay. All right, so we're just measuring the temperature of this hydrothermal fluid. Now approaching 60 degrees centigrade. Yes.
Oh, well, look at all those tentacles, though.
Okay.
I'm really sorry, guys. I never wanted a time. I just want to be.
All right, 75.
I guess because I got an email from Victoria.
Okay, what do we got?
All right, we're almost at 90 degrees centigrade.
The last day.
So these fluids are coming out toasty, approaching the boiling point of water if we were at the surface. But of course we're here at 3,661 meters, and so those high pressures allow for fluids to be superheated.
They said 5 centimeters. Victoria 90?
90. Yeah, 90 looks like it's,
Yeah,
yeah. I was hoping.
I know.
Okay. Okay, we can pull out.
Can't just will it to be higher.
Night. Will it to be higher. Okay.
Alright, let's do it.
And then we're gonna do a profile in the sediment near it. So, no, we're gonna keep probing. So now let's go over to the right here into this gray sediment. Just a little bit east of the scale worms. And let's try to do a temperature gradient. Yep, that looks great.
5 centimeters.
5 centimeters. Okay. While we're doing that, I'll zoom in on this picture.
Are you clicking on the temp probe tab? Yeah. Okay.
I don't know what it is.
What is it?
Mystery.
Weird. Yeah. Here come your worms.
This is a Penile pollinoe scale worm that's endemic to this environment. It is my namesake worm, so I'm particularly attached to it.
17. C calls it 18. You already type it in?
18. Okay, we can go another 5. Yeah, to go down to 10. All right, 23. Seems like there's a ton of fecal material too in this whole area. Look at all that. How are we doing? Temperature stabilizing? 30. Seems good at 30. Here we go, another 5.
Graham, how high do you think that flow is a meter off the sea level? Yes.
guess.
Not very.
3?
Yeah.
Two,
Okay.
three.
Okay.
Yeah.
My arms in it.
Yeah.
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 We're good. Nice and well.
All right. Should we go another 5? Yeah.
Was that 10?
That was 10. Now we're 15. Okay, it's going up again.
Every now and then I think the Schmidt logo is a blue worm.
What's that?
Every now and then I think this Schmidt logo is a blue worm.
Yeah.
And this logo?
Yeah. Are these Arcanoni?
Yeah. Firework.
It's pretty consistent with last time.
Little fireworms. It's consistent in terms of the temperature?
Yeah,
Or
so
this, the look of
it's about the same temperature as that. So that's the active flow. And this is about 40 degrees at 15 centimeters.
Great. We're about 42. If we can go another 5. What was it at the deepest part?
Another 5?
80? Yeah, let's go another 5.
The hottest one was 90.
Okay. That was our hottest we measured here.
Yes, but that was at 30 centimeters. So the hottest at 15%.
Okay.
Oh yeah. Then you can count the rings. This is 25. That's the
Kind of holding at 48, 49. Okay, so let's call it 49. Let's do another 5. Sean, I was wondering if there's another one right above. Do you see this? You think it's another one?
it might be a picnic on it.
Okay. But do you think the other one up above is also a Pycnogonus?
Oh, that's what it could be. See?
Yeah.
Picnic on it. It has a right here. That is a picnic on it. Yeah. We've been getting a few of those.
YouTube for the win. Alright, 58. Are we stable? So good. So let's call it 58. Alright, and go another 5. Our angle changed.
Bring me, camera back.
Yeah.
See, I can see it.
Yeah.
See it. It's good. Alright, that's pretty much the end of the
Okay. 60.
You gonna do an aluminum core over the.
Yeah. We'll see. We're gonna try to push in the sediments there next. See if they-
Yeah, so that would be comparable to 199.
Let's call it 64. Okay, so we can retract the.
Yeah, so in 2018 we cored in focused flow in a white mat with arrow vanilla in this area, and we got we harvested 14 centimeters.
Okay. And what was the temperature max?
That
Okay.
that one was 75 or so
Okay.
at
So
30 centimeters. Not 100% sure it was a good number.
yeah. So Chris, can we
I
do?
need the camera for a second.
At
Okay.
15 it was 60.
Yeah, 15.
Move to the right.
Okay.
Which we've already beat.
Are you caught?
Yeah.
We got wrapped around the nozzle of the suction sample. I'm not moving forward a bit so we get it. Yeah. Keep going. Watch out, watch out. That's fine. Yeah. Just want to swing down.
So we'll probably have Greg in the control room a little bit later to tell us a little more about these scale worms, but my understanding is that the scales are kind of like your fingernails. They are made of chitin. They're a little bit rigid but flexible, and they do remain this beautiful blue iridescence, so it's a little like a butterfly wing in that regard in terms of the light Ooh.
Careful of the sediment.
Yeah. Yeah. All right.
Now to secure this and grab the
Yeah, no problem.
you stop it on this push across the let's take it. Yep.
We just got a little bit of a tangle. The temperature probe and the slurp are Well,
That's it, Chris.
All right.
And back on.
Yeah, you want to be gentle. Make sure you put them back down. Land on that console. Up a little higher. Alright, should be good now. Back. Stable.
well, there won't be sampling these mats. There won't be sampling these mats.
Alright. Sorry about that.
Okay. So I think we'll do a temperature probe gradient, but we may have to move to do coring and do another set. Let's,
So,
let's see. I do want to get a profile.
it won't happen now. This is when the thing is.
Around the small green.
What's that?
Keep it around. Take over all of the small green. A bunch of
Maybe we'll have to check it up and see if that's gonna happen.
You think it's going to keep getting caught?
Not where it is
Sir?
right now. It's just that the way that it's sitting, you got caught up on the nozzle the first time, so now the nozzle's out of the way.
Okay.
Toss it to the side.
Yeah.
So it won't happen again.
Is the nozzle dragging in the sediment though, or is it secured above?
It's dragging right
It's
now.
dragging, okay, right. So, as we move, the nozzle's in the sediment. So,
It's. I can put it back on the magnet, but it's gonna do the same thing again. Just because of the way that the cable and the
Yeah. But we can pick it up
Yeah,
when
we
we
can-
move, so
yeah,
then it won't,
once
you know.
we get done with this, we can secure it and I can grab it.
All right, so it's cleared up a little. Now, can you reach that white patch that's to the left of
To the left of
the hose?
so we just moved a little bit south this way, so we just bumped down a little bit. Pan up so I can see the former sites. Okay, they're right there, those two. Okay.
Porch down right there.
porch down all the way.
Bring the camera back just a little bit.
I did, it's already back. It's clear.
No, back more.
Back forward?
Back more. Trying to get a view of that white. There we go. Let's get it back.
All right, 15.
So we're going back a couple of years, so up ahead of us is still where we were.
Yeah.
Focused flow,
Yeah,
less distant.
we can.
Might be.
So the fluid, the higher flow fluid is still up off to where.
Yeah. Yeah, if we,
Where's the gray map that we did the temperature probe? Is that also there? And then we just slid down?
yeah, we slid down. So
Okay.
this disturbed area
Got
is different from
Got
what
it.
we're looking
Well, that's good.
at. If you pan up, we were set well for this right now, but
Yeah. Okay.
yeah, it's,
Yeah, I see it. We just slid. All right.
Yep.
So 22. Go with 22.1. Okay, let's go another 5. So around 23, 27, 29, 23.9, 24. Let's go with 24. Okay, let's go do another 5, please.
What was that?
24.
I don't have an overlay back there.
You don't, yeah, it disappeared off the.
Oh yeah, yeah. Okay.
swing to right a little bit down.
What's that?
Right.
4. Mm. 35. Let's go with 35.7. Okay, let's try another 5. Must be pulling seawater in.
Alright, now we're on that. Yeah.
This might be your last one. No, in this position. at
Yeah,
least.
okay. So it's soft, but it's the angle you're at that's the issue? Yeah.
Well,
Okay.
I might be able to like maneuver the arm to get it in, but then you hard
Yeah.
to see where we're at.
That's okay.
But since the next one's gonna be the tip, I can use that as a reference instead of the little.
Uh-huh. Yeah.
This position's the only way to go and see.
Yeah, yeah.
We know where we are.
Yeah. Well, we could probably call it, right?
Yeah, I think so.
All right, so let's go with 42, and then that's going to be the end of the profile. What up?
If you want to go deeper, try to like go out since I don't get to see
Yeah.
it well. Or would you rather just
It's okay. Yeah, it was. Let's we can go to a different spot. All right. So we kind of slid down a little bit.
yeah, came back.
Yeah, and this area is pretty mucked up now. So I would like to try to bump up and do a similar temperature probe in the white mat that's next to the more vigorous flowing off to the left, upper left there.
Yeah, there's this flow here.
Yeah.
I think might be our original.
I think that's right. I don't have the iris again. Yeah. Yeah, go ahead.
Up a little bit?
I do want to bump up, yeah.
We're still going to be doing heat probe.
Yes.
Standard operating for most of the time.
Oh yeah, that's
Yeah,
interesting.
no, that's at least thing. It's not a good thing.
Shake it.
See the camera on top in front of me,
Oh yeah.
Victoria? You want to
Yep.
park, or do you want to core around here?
I do want to core right around here. Yeah.
Okay, this is pretty much where we were before.
Yeah.
You can see our skin art up there. Come back a little bit.
Right. So Sebastian did a little sliding down the hill, so we're just trying to reposition so we can take some push cores and some additional temperature probe measurements. Okay.
Steve?
Are we good? Yep. Okay, so let's do, I want to do another temperature probe in the sediments,
Okay.
but I want to leave enough real estate to take a push core. So this, this area behind where the vigorous venting is happening. You think you can get a temperature probe measurement and a push core back there?
On the back side of the thing.
Yeah.
Yeah. I can do like a push core. Or I can do a temperature probe right where the worm is to the right there.
Where are you looking?
Get the vent, making a smaller vent.
Oh,
In
this-
between. Right.
Over.
Yeah.
Yeah.
Maybe temperature probe like right in here and then push core over here.
Yeah, we want it in the white if we can.
Oh, okay.
Yeah.
Okay, so right down there.
So yeah, if you can do that and next to it, is that possible?
Alright.
Yeah.
Where are we done?
Alright.
Page your camera for your quick mock up, so you want to take the time.
Monica wants an image without
Yeah.
this in it.
Yeah, I know.
But yeah.
We all would.
What I can, if it's little, I can try to move that cap off.
Yeah. Well, which core is that? Are they all? Is it an aluminum sleeve?
Yeah.
Seven.
Seven.
I can take it off and just move it in between cores so it won't be
Well,
visible.
we'll probably take some cores here, but we need the aluminum sleeves maybe.
Yeah,
if
that's
it's
gonna
hot.
that's gonna be a. I think polycarbonates are the low numbers, plastic ones.
Right.
Yeah,
Okay.
so that's a plastic one.
But you can still take it off. Maybe we can do a quickie.
Yeah, it's just-
Yeah. Yeah, go ahead and pull the.
Yeah, I wouldn't do that one over the float.
No, but we'll take a few cores here,
Yeah.
so we can use it for that.
I did try to fold that out. Yeah, I made them really stiff so they'd be easy to grab, but then just fit her to be a hip shot.
I
Replace the monkey fists with handles.
I like having them easy to grab.
Yeah.
It might not.
A little better. Let me just zoom in a little. We can get the arm out of there.
Alright, so back side of the vent is in the vent, or next to the vent is still in the way.
Yep, but we want to hold it steady just for a little bit for Monica,
Alright.
since we made this clam shot. Oops, sorry. And I don't have iris control anymore either. Very good.
Ready?
Yeah. Do I have iris control?
You should. I can do it over here.
Yeah. You want to bump it down one? Yeah. Yeah. So now I've got control. It's great. Thanks. Now we got some paraalvenelids and some little red copepods that are in the diffuse flow here. All right, so we're ready for some temperature probe action. Go for it.
Sweeper. Let's go down. Alright, let's get right there.
that all of the mats here were not really above 90?
That was what we measured.
Okay, so it's not really mats here. I mean, there are more mats,
Yeah.
not above 2 limits.
No.
570.
No.
Yeah.
Okay, that's 5.
It's 5, okay. Temperature's going up. Yeah.
Question is whether if we get a good
Good measurement.
good measurement deep, if it would be hotter.
Maybe.
Because, I mean, so for these measurements, I'm not. It doesn't make sense to me that that our temperatures that were outside of the focused flow areas were lower than the ones in the. I mean, ones in the focused flow were lower than the ones outside. That doesn't make sense to me unless it's seawater and trained. But that's what we have reported.
We're about 28. Let's call it 28. We'll go another 28.3.
0.4.
Is it still climbing?
0.6.
Oh boy. All right, hold on.
0.7.
Still going. Now it's jumping around. Okay, 28.7.
98.9.
Ah, okay, push it in.
Alright.
Okay, 10 centimeters. Yeah, most of what you see here, that white flocculent material, is microbial, likely feeding on hydrogen sulfide, possibly some hydrogen and methane that's coming out in the venting fluids. We'll collect some of this material and that'll give us an idea of the diversity in here. So it's, even though it looks like it's all sort of one type of material, there's quite a bit of diversity of microorganisms that are living within that mat. And we have large filamentous sulfur oxidizing bacteria potentially that make up the primary structure of those mats, but then there's a number of other microorganisms that also live in there, and there's a lot of tight geochemical cycling of sulfur and carbon and possibly other elements that are occurring within these complex microbial communities.
We're gonna look up for just a second. That's okay.
Oh yeah. I'm gonna look up for. Oh yeah.
47.
Okay.
48. Let's call it 48.8. Yeah, almost. Okay, we can call it 48.8.
Alright.
Okay. Another 5. These?
So the temperatures that we measured here in 2018 were the second hottest that we measured overall on that cruise, the hottest being
200. Yeah.
I think it remains a question whether how much seawater entrainment we get, how much
Right.
cooling down we get during these temperature measurements. There's some amount of luck we can get in there.
Yeah. All right, 64, 65.
The group is gathered in the break room, at least some of them watching the live stream.
Great. Give a little shout out to the folks watching from Caltech. Wish you were all out here with us.
You just have your lab meeting right now. We could all listen.
We could. They are.
They're listening to us.
Yeah. Yeah. Yep. It's pretty amazing technology to be able to share our deep sea dives with the folks back home. And of course, there's limited numbers of berths on these cruises. I would love to be able to bring everybody out with me to see, but at least this gives people a chance to see what we're seeing on the seafloor in high def. Okay. $68. Let's call it 68. All right, let's go another 5, please. Okay. I think we're maybe pulling some seawater in.
Does everyone know? I think that. Oh, never mind.
What?
That's an hour ago. Audio was gone.
Alright.
That's the visual way.
It'll be a fun.
That could go in there.
Hmm.
Would be a problem.
If you let it go, will it snap back?
Yeah, awesome.
Okay.
Yeah, there's not a whole lot of the seabed is not very firm, so it's not going
Yeah.
in there. It's just gonna
Full. Okay. All right. Looks like it's about 70.
Yeah.
All right.
Do you want to do something else?
Well, we were thinking about maybe taking a core, but we want to confer with.
I could try it. If I do it and it flips up, it'll just
Yeah.
go like that.
Yeah. We'll see. Rebecca, what would you like to do? You want to plug a place you want to core? Do you want to keep looking around?
Well, it's nice that we already have like 10 pro data. So I don't think we're gonna find hotter in this area.
Yeah, maybe a little hotter, but
Maybe a little bit hotter.
so you'd be okay with 4?
Yeah, it matches up with last year's like temperature data.
All right.
And I think we're, it's just like a more difficult spot to, I think it'll be good.
Okay. All right, so we're going to gently pull the temperature probe out, and then we'll try push core.
See how that goes.
I'd like to do one of the aluminum ones. I'd like to do another one if we can, just to, I guess, I don't know. Maybe we could put it in. I just wanted the sulfide film may react quickly.
Yeah. It's not sulfate. I mean, it's a lot of sulfide.
Yeah.
What's the downside of doing an aluminum one besides the fact that you can't see anything?
Yeah, I wanted to see if we can see what's happening.
Singular downside.
Yes.
All right.
What's another
And
downside?
if it's not, we're not measuring temperatures, it's gonna melt the
No, we
core,
haven't gone above.
I think we can
We
probably
haven't gone
do
above
it,
90, so I think
and then we could
just
at least
use
see
number
what we're
7.
getting. Yeah.
Yeah.
But wait, oh, you're talking about in that spot? Because
Yeah.
the other spot was 90 at 5 centimeters.
Yeah, but it won't really melt until 150.
Okay.
140.
All right. But that could be easily under the first spike. Because it was at 90 at 5 centimeters.
That was in the like.
That was in the
Yeah.
orifice.
Yeah,
of the-
it's just really close to the. I'm just saying.
yeah. Well, otherwise then we'll have a nice, Dolly-esque art.
Dolly.
We are the ship's surface.
Yeah. Okay.
So we're gonna record next. Is it the plan to record next to the?
In the white next to
Yeah,
the
not
hole.
not like
over the
on the
hole.
hole.
Yeah. Yes. Yes.
Could be very soupy.
Right. So now that we have our chemical context, we're going to try to take some push cores. And that'll allow us to sort of relate these temperature probe measurements to microbial communities with depth in the sediments. And one of the cool things about doing this kind of work with the ROV is actually being able to see the seafloor and take these sort of precision samples in spatially confined regions like these little patches of microbial mat that would be really hard to do with the kinds of other coring capabilities that are done off the side of the ship, like using multi-cores or gravity cores or piston coring.
That's it.
That's not even on. I'm trying to get more voices. I don't know. I just think it won't matter because it's their own camera. It's HG2 is the one I can see with it. HG2 is the one I can see with it.
I'm loving this new location.
Yeah.
Put it between,
You just hold them for now.
like the way the water flows.
Yeah.
To what?
If you stay over there, watch out. That thing is that will go. It's just like,
Alright. I don't know if I'm on the that kind of. So you that's the problem.
Yeah.
Can't see how deep it is.
Chris, could you put it in between the
What's that?
Could you put it between the quivers and the milk and the cores? Would that work?
yes. Yeah.
In it, I guess. Might be tricky.
Thanks, dude.
Yeah.
Okay. Stay.
Alright, 7.
Number 7. And we'll do a very short marinade. Try not to melt it. But it's got the sulfite film on it.
That looks plastic to me.
Hmm?
That's okay.
Okay, it's okay.
Yeah.
Alright, bring the camera. Still in the white next to where I did it.
Yes, please. Yeah, to the left of that.
Yep.
Yeah. Try to do it over the para-albanellid.
Alright, stop.
They're up higher than up. There's the one.
Maybe.
Oh, I see where you're going. So they're good.
Rusty?
Is crusty? Hard?
Yeah.
Wait, hang
Or-
on, maybe.
I can get through it.
Okay. Alright.
Alright.
I know.
Maybe.
Oh.
Destroy that.
Oh.
Want to keep going?
No.
No?
I don't think so.
Alright.
The whole thing is just.
Oh, you like, holy cow.
You could still push core over the parallelids if you
Yeah.
take it out. If you don't care about that core now.
Yeah.
See him over there?
Yep. I do. Okay, let's shake it out.
Oh, you got a little vector going on.
Okay.
Alright.
Well, let's try again. Do you see these little... para-albanellids? Yeah.
The white.
The little... Oh, the ones that just retracted. They saw you. How is that possible? That's so weird.
I got you.
So right here. Here, let me. That was you couldn't have like planned that better. That's so bizarre.
That was
okay.
Red thing there.
Yeah,
Yeah.
these little guys right here.
I'm not going to point at them again because they're scared of me.
Yeah. John scared them.
Did they retract right as you poked at the screen?
Yes.
They sense the force.
Yes.
Can you zoom in just a tad, Victoria?
I can. Whoop, I can. I can really zoom. Hold on.
Photo. Frame grab. Thanks. All right.
All right.
It was hard enough that when we were going through, it started to just
Yeah, just totally made a mess.
Ready?
Okay.
Okay. Whoa, it's gone.
Keep pushing if it works. Yeah, okay. It's good. Just wait a couple seconds. Yeah, yeah.
Push your luck.
I know.
How was it?
Not
And gambling.
not horribly hot, but it was warm. Like 70.
Oh, that's not too bad.
Yeah.
So,
All right.
clarify, is this to the right of HT4 where we just did, or it's to the right of HT1?
That's probably good, Chris.
They're at the same
Because now it looks like they're not at the same actually. The first one was over here. We did one.
Yeah.
And then there's another one here.
one was like in the workforce, one
Yeah.
is
That was HT4.
yes.
But is this the upper? Is there shimmering water into that actually? That is location. Like,
We took one here for the dry sediment. And two white.
Pretty rocky.
we did, but there are 4. So there was 1, and then gray sediment, and then down on the white mat, and then back up to another near high temperature. So, yeah. Yep. Down to white, down one, and then we can end up speeding back up into the white mat above the one. So the second one. Yeah. So we're all up here now.
It's melted?
The gel was stuck in there.
Oh, the.
Whoa, what? The stopper? The handle
Yep.
melted?
It was stuck on there. Couldn't get it off.
Oh yeah, you can see the.
Oh great, Victoria.
What?
Will it actually seed? Because it seems like it's not seeding either.
No, not at all.
It's
warped.
melted.
Okay, well then that means it's hotter than what we
It-
measured.
Yeah.
Okay.
Uh-huh.
Well,
Biobox? Or do you
I
want to
don't
just
know.
let it flop around
Do you
like
have
that?
anything in Quiver 7?
there's nothing in Quiver 7. You gonna put push core 7 in
You
Quiver
could,
7?
you could put 7 and 7 and then maybe put your worms into.
Well, if it's cauterized or warped, you think it's just warped? It's not.
It's probably, didn't look like it was caught, or it didn't look totally warped at the bottom.
Yeah.
So it's not going in at all, Chris?
No, it's
Yeah.
like
Okay.
inches.
Let me just torch you.
Okay.
Okay.
Curious.
Well, there's that. So what do we, if we put it in the, if we put it in a bio box?
I mean, you have plans for biobox.
Yeah.
And you can shake it into a quiver.
Okay.
7 into 7.
Yeah. All right. Let's try to shake it into Quiver 7. I like that idea.
Shake it
Into Quiver 7, yeah. We'll at least get the paranalvanillids and maybe the crust that's on top. John, which ones have the aluminum?
Back 4. The high numbers 11, 12, 101, 102.
Okay.
I feel like tomorrow we should probably put aluminum down one side and polycarb down the other.
Yeah.
Then there's always an option.
Yeah.
Sit in the back. Set yourself up for success.
But that was useful.
Looks like it all came out and it's all in niche.
Yeah, that's what I was afraid of.
Well, that's
Yeah.
fun.
Stow it.
Okay.
So we can stow the empty core in the bio
We can
box.
put it in the bio box.
Oh yeah, you know what it probably was? You probably got a big chunk in there.
Yeah,
and
so it
it-
didn't melt.
And then when he went to
That
put it in,
works.
it was
Yeah.
Such a slit out. Okay, I take it back.
Okay.
So not worth.
so.
Can you turn it around so we can see the film at least? Okay, so there's some good staining on that. All right. Great. Perfect.
Yeah.
Okay. Maybe we can throw it in the bio box? I don't know. What do we do with the core? No,
Yeah,
with the-
okay.
You can throw it in a bio box. Or
I don't want it'll float away if we throw it in the milk crate, right? So
Yeah.
Yeah, probably.
I feel like the bio box is the
Probably the best idea. Okay.
place to. Okay.
Slide that. Yeah, 'cause I don't want it on the porch right now.
So we had the misfortune of one of the rocks that we cored over falling out in the core quiver, which meant we couldn't seat the push core. So now we are going to try to stow this core in one of the bio boxes.
Well, this is a lesson in how every single sample is precious.
Yes.
Hard fought.
do you analyze that paper on the side of it?
Yeah.
No,
What's that?
there's nothing that went in there, yeah.
Yeah.
We caught a push core?
We caught a push core. All right.
We will give that a sample number because it has a film
Has the
on it.
film.
Oh, okay. So I'll log it then.
Yeah.
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 Alright,
Yes.
good call.
That's called push cord light. Okay.
Did that go into bio box good?
That went into bio box 4.
Yeah.
Okay. Well, what do we want to do here? Do we want to try again? Move. Okay, we should move. Okay, let's try somewhere else. Well, we just keep cruising over here. We'll see if we find a spot. Should we pick up the slurp too, or?
Yeah. Good call. Get it.
Alright, good.
Oh, lost the top.
That's not a problem.
Good thing it's tied
Is
up.
it it's attached? Okay. It's okay. We'll use that quiver. Just
Alright. Here.
okay.
Right.
Okay. Let's look at this other little spot here.
They're elevated. Rocky outside.
Yeah. Yeah, definitely rocky. So if we keep going, we're gonna reach the original Pushcore site. Is that right?
Are those folliculinids or just bacterial mat?
It looked like they could be folliculinids.
Yeah, if we keep going, I think we should reach the original
Okay.
site.
All right. So we'll just keep creeping along. We'll see if we can.
Are you,
Fine.
you want to head to this mound to the south here?
Yeah, I think. Yeah, this other one up there. Let's see.
Oh, sorry, you want to head north?
Head north.
He went,
Yeah.
He went
Oh,
south.
Yeah. Yeah. Sorry.
Sort of there.
Yeah.
Just in the north.
Okay. So we're gonna head north a little bit to another area that we had identified microbial mat in. That's just slightly north of us. You can really get a sense of how patchy these hydrothermal vent areas are. Sort of popping up like little oases in an otherwise pretty muddy deep sea seafloor. We know from our colleagues who have done extensive heat flow measurements in this area, though, that the sediments are warmer than what you would expect outside of this general venting area. We're coming up on some clams, looks like.
Yeah, we're heading north. Northwest.
One expensive photo paper.
This is one of the clamor areas that could be good for the heat flow thing.
Yep, we'll come back
Want
to
to
it.
come back to it,
Yeah.
because it's kind of isolated.
Yep. Put a waypoint. I don't know though. It looks doesn't look very. Looks like a lot of anemones on.
Yeah.
Doesn't really. I mean, actually, it would be a good test. See, because this looks mostly like plant ash, and so we could see if the heat
liver-
flow is
Yeah,
yeah.
that would be nice, wouldn't it?
Yeah.
I like that.
So we're coming up at the on the base of these are the beginnings of the rocks.
Yeah,
at the
so we
base
should
of the
be
mounds.
more
We
to
wanna-
the east.
It's,
Or east.
Yeah, not further north.
Let's kind of just do a little transect and see if we can find. They should be associated with this feature that we're on right now.
Okay. So what do you
Yeah,
look
just sort of east
More
west back
microbial match.
across.
Yeah.
Okay, so I'll turn east. I'll go maybe 20 meters out. Turn
Yeah.
around.
Yeah.
Yeah, if we don't see it, we should
Yeah, because
turn
I think
around
that's your
and go.
feature up here.
Oh yeah. Okay.
Yeah, they're naming ours.
What's that?
They said the wild push chorus called Push's Chorus, and then somebody said, no, more like Chorus Nopius.
Hmm.
Yeah,
Alright,
I
must
think,
have
I think
missed
back.
Okay.
The
Let's.
other direction.
Yeah.
Yeah, this looks like we're going kind of up that little mound.
Yeah.
Yeah. So if we go west from the mound.
All right. So this looks like it was once a very active clam bed, chemosynthetic clam. So it's sort of now, it's like the plumbing has shifted. So these now all we see is the shell hash. Don't see any evidence of living clams. There's our friend, the xenoturbellid.
Yeah, we're a little, we need to be a little closer to the mountain and the growth on the talus. And if we take another pass back the other way, we should come across it. I think
Yeah.
We're too far south, I think.
Okay.
A little bit more north.
We're too far south.
Yeah.
So
It
go
was pretty close to
southeast.
the mounds. So I would just make a loop around to the right and make another pass.
Yeah, I'll go up 10 meters
Okay.
and then we'll pass to the west.
That's
Yeah.
Or
perfect.
the
That's
east.
exactly
Yeah.
what, yeah. But I think that.
Another
I'm hoping
pass
we're
to
gonna
the
see-
north or another
Yeah.
pass
No,
to the
no,
south?
to the east. Another east-west pass.
Yeah,
right?
yeah, but
To the north of where we
To the
north
of
of where
just
we are.
were. Yes.
Yeah, right.
Yes.
So closer to the
Closer to the mound.
to the mound.
Yeah,
Yeah,
because it was
yeah.
very close to the talus. In fact, and that piece fell off of the mound and couldn't
Right,
have gone too
right.
far.
So we're looking for that flange.
That, yeah, the land or the man.
That was our launch point.
Yeah.
I'm gonna if we end up landing on that dot, I'm gonna.
So do you recognize this feature?
Yeah, that's the big bomb right there on the block. Then we're going to come to the next block.
Yeah. Then,
Yep.
And you think it's somewhere behind that?
I think it's right around here.
south of those two.
Those are
Yeah.
the two big knobs right there. There's one.
Concrete got roped into it.
If we don't find it, it's possible it's actually hiding behind these blocks. We have to look back there, but there should be in front of it. But
Okay.
Yeah.
that's the only other place I can think of where it could be hiding.
Yep. There's one of those big anemones in the distance there. Huh.
I wanted to see much of it. It's like a blob.
That's
They're like
a
impressive.
planned cheese. That's not the one that's in.
Yeah,
I think we're very close.
maybe just up here.
I think so, yeah.
Yeah,
Top right.
yeah,
I think that's probably what it is.
be coming onto it.
No, that's planned.
Let's see if there's anyone home. Yeah, and it's looking like a lot of shell debris. Z, did you guys see this on Lake 2?
Maybe, yeah,
You did.
went over this. It's maybe down at the bottom of this slope.
Okay.
I'm not seeing it. I'm not seeing it.
Hmm.
We gotta be so close, I don't know how we're not seeing it.
Hmm. Well, we can do another pass the other way, and then
Yeah,
could also,
to the north,
No, the
yeah,
east here.
yeah,
And then we'll do pass to west.
yeah.
yes.
Okay. You see something? Alright. So we've got the sonar up here that's giving us some information about structures. Things like the clam hash will show up on that in these big blocks. And we also have the seafloor bathymetric maps that we're using to sort of guide us. We have an overlay of the ROV SuBastian. That is a SuBastian footprint,
From 2018.
maybe.
Did you guys come here, see? Like to?
I don't think this is us. I don't think we came here.
Hmm.
We might have done a heat flow right here, but I don't think this is older.
Seems old.
Don't those look like old tracks?
They do.
I think
Well, it
this
could be
might
from
right where the
2018.
man was.
Oh boy.
Do you have a picture? Do you see if those blocks are the?
Yeah, we'll take a
If
look.
you just go, actually, go just a little bit north. If this is right, we're gonna see that upside down flange.
A little bit north.
Just a tad, a few
Yeah.
meters north.
Looks like north is going to be right into this.
Yeah, it's right next to the mound.
Yeah. So maybe everything's shifting.
I got a feeling we just passed it.
Yeah.
Yeah, because when we were here in 2018,
Yeah.
this field
Now
had
just slowly lateral over the left.
we have a
Turn
lot
to the
of
left. So there's the edge of the mound.
a lot of clam hash, but also a lot of clams. Whereas now it's all hash.
Mhm.
This
Yeah, I think.
Do you recognize
if
the
I'm
flange,
right,
though?
The block is right underneath us. It would just sort of go back a little bit backwards or just swing around to the left more. It should be right in here. Just past these big blocks, I think. I think that was the sign.
Ephemeral habitats.
Yeah.
That's me almost facing due
Is that it
south.
right there? No, it's not that small, is it? No. You said a meter?
Let me.
Yeah, it's about a meter.
Or
I'll just back up, see in case we're actually
Yeah.
right on top of it. Is it quite small?
Yeah, it's about the size of that block right there.
Yeah, exactly.
But it has more of a distinctive shape that I was looking to recognize. That might be it right there, and it's just more sediment covered than it was before. That
Yeah.
looks kind of similar.
Hmm.
Yeah, just, if we just keep backing
Got
up,
it.
I think it's got to be right here.
One of the mounds. Is that no? Is that it?
This is the
Yeah.
upside down flange.
Yeah.
Oh.
Yeah.
Yeah, different.
Let's see what it looks like.
I mean, it could
Unless
be
it's covered in
could be
sediment,
filled
but
filled in.
If we're seeing the tracks of the sub, I doubt it'd be covered in sediment already.
Yeah, that's true.
True enough.
It's true.
Let's let me just scoot around to the north
Yeah,
on
yeah.
this. Maybe it's further around that
It
side.
could well be.
How high is this structure?
With the block we're looking
Yeah.
for? Oh, it's that high.
This one just
Oh,
Cavern.
the big thing?
Yeah.
That's 25 meters.
Okay.
That's the big mound, yeah.
Here's the flange with Sebastian's arm for scale.
okay. Sponges.
Plenty of anemones.
Lots of asbestobluma sponges. Those little. I must see it's on
Yeah.
the west side of this
Yeah.
because I haven't really gone
Yeah.
over those two knobs right there.
All right. Hunting for the elusive microbial mat.
It's too big, I guess.
Yeah, this is
Yeah.
now going up the side
Yeah.
of
Yeah.
the main mound structure.
Let me just kind of back off and see.
Yeah, if you go west on the backside, I guess we haven't looked there yet.
Yeah.
That's not it there, man.
That is a piece
Oh.
of footage, but that's not a piece of footage.
It's,
We can't be more than 10 meters short.
yeah, it does have a really distinctive shape. Huh. So out of if you drive like west in between the main structure and the two knobs, let's try that.
Up front right here.
Aquí al frente tenemos a nuestro protocolo que está haciendo todo el vuelo de lo que es el RV, ahora organizados como protocolo. Él se encarga también de manipular y hacer todos los movimientos del brazo. Y al final también él nos ayuda. Y bueno, básicamente
Yes, this is the
Now we're going over
the block.
the block.
The,
Yeah.
Yeah, just come in between the structure and the block.
Yeah. There's plenty of flange here.
yeah.
I don't even think we could core this even. Oh, wait. Going up ahead. Maybe. Is it a block?
It's possible.
Block.
Yeah.
It's active. Yeah. So what we're looking at here is a really large piece of flange that has fallen off of Tay Ujaa Cavern. You can see the white hydrothermal calcite, a little bit of sediment cover.
Okay, so see all that flange debris just go right up there, and I think that's and just right out that way. Yeah, that looks like it might be where it was.
Little jungle.
Yeah, a little further away from the well.
Looks so bad.
Yeah, so
Bridge RV. Maybe turn that way.
yeah.
What changes there?
Yeah, so yeah, just follow this down. I have a feeling you're gonna find out.
You can see the little sonar inset here. And again, we can use that as additional guides to trying to find some of these seafloor features.
Yeah, swing, there you go. I think that's gonna take us right to
Yeah, I'll swing around here a little louder.
perfect.
Have a look at that. Sorry. You guys will be up to so that's the first
Yeah,
Yep.
that's,
Seems like it's south of that.
yeah, that would want to be a little south.
more south.
Yeah.
Okay.
South of that. If not, we'll head back to the other round, I guess.
Yeah.
Way up here to the top, I understand the kill the visitors.
Okay.
No, that's good because in case it's further away. Alright, so let's pop down here. You happy this first out here? See?
Yeah,
Yeah.
I got a feeling that those tracks are
It's
further back.
yeah. So the offset between the 2018 dive track and this map is about 20 meters south.
Yeah.
And based on moving stuff up here,
Yeah.
and that puts us in this area really just
Very close to that.
very close to that mount feature.
Yeah, just seems like we had to have driven over, not
Just
seen.
just south of where that white is.
Right, and that is the rock
Which is the dive
location.
Yeah.
Do you want me to come back down to right about here and we'll start heading north and just kind of back and forth like this?
Yeah,
Yeah.
Yes.
We kind of did this east-west here, but I think we may be missed
Yeah.
it somehow.
yeah,
Yeah,
that sounds good.
So I'll come just due south of the white waypoints and then we'll make our way north. Sorry, you said the map was offset 20 meters, so should I maybe head a little bit further south?
No,
No, I think if you
no,
move around right there, you're good.
no. I think that's because my map is offset different from your map. So I don't want to get into offsets.
We must have flown over and not recognized it.
Yeah.
Very nice. We see the blocks.
So that's us to the south, kind of laterally east and north. Got something here about 20 meters out.
How big was the feature last time? You know? How big the feature was? The mat?
This was the
Sorry, I just saw it.
and so this
That's
is
farther, I got something right ahead of me.
Yeah, that's
There's
the
also-
big blocks right
that's
there.
why I
There's
think
also a
that
couple of
if
things
the flow has shifted, and this is the wall hash instead of flow patches,
Yeah.
It would have grown and flown over.
it would go from
That's right on top
just
of
dating totally nondescript.
But this would be where we are, right? So if it's all just
Yeah.
clam hash, then
Then
that
we-
explains it.
Yeah. In which case we
Yeah.
move on.
Trash. Did you mark the trash? Okay, so
Wait.
stop.
Look at that on the right. I see layering.
That's it.
That's it.
That's it.
Okay.
Yeah.
We
Can
found
we
our.
drop a waypoint on that?
Oh, you didn't have fun searching for it?
Thank you.
We were literally
Yeah.
2 meters still.
Do you want to land out
Wow.
here for a sample?
Oh, and look behind. Maybe that's. No, we don't want to land just here, but we want to. This is the area that we want to potentially
So the-
sample. If it's
Yeah.
Yep. Okay, so
So the-
minor success. We found the flange piece that has a really diagnostic shape, and it indeed looks very much like the picture we had in 2018. So the good news is we know we're in the right area. Now the question is the fluid activity shifted since 2018, and will we find adequate places for us to collect samples?
From my note, the map should be about 4 meters that way.
Yes.
Oh, yeah,
And
down
if we
from us.
see the-
south.
If we see the tracks there, that
Yeah.
was the map.
Okay.
Yeah.
And if you're willing, it'd be really nice to sit down there and do a heat flow, because that's
Sure.
just where the really high heat flow was, we could see a change.
Yeah.
Yeah.
Okay.
Yeah.
Yep, we can do that.
So this pink diamond is the flange,
Yeah.
and the circles are the push course.
Okay. So can we go like 4 meters behind us?
Sure. Due east or west, right?
Do
Would be to do south.
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 South, sorry.
where? So we're also looking to see if there's evidence of us sitting down here or
Yeah, so I'm basically almost due south of that right now.
okay.
Down about 8 or 9, maybe 10 meters south of that.
Okay.
Yeah,
How many meters out?
8 or 9.
yeah, let's creep forward a little bit. And I think we're gonna find subtracts.
I was just wondering if this, do you see this little
Yep,
nub in here, if that's that,
could be.
or it's hard to tell.
It's very hard to tell. There's also
On national lawn,
Could be that same fish.
yeah, I was just thinking that
It's multiplied.
Fish seems to have moved a little
Yeah.
bit since 2018.
Hmm?
yeah, just off to the right there.
Yeah, so that's the flange back basically. We just came around it from the other side.
This is the flange we're looking at?
Yeah, because he's on a 3 meter scale. It's right in front of us. Do you want me to come further south?
I think all this clam hash is where the mats were.
Yeah.
Yeah.
Now we're just looking for subtracts next to it.
Yeah.
Yeah, those subtracts were kind of. I think they're behind me. Do you want me to go back to them?
Yeah, how far
They're
behind?
not far away, I think. Right in this area, so just.
Yeah. So we could stop the same place as the subtract and do a heat flow
Yeah,
there.
I think that'd be brilliant if we could do it.
Yeah. But this is definitely not,
Yeah, this,
This looks
the
like what I
mat
did
is
before.
gone. This-
yeah,
This is familiar. Yeah. that's what I
yeah.
see.
There's, okay. So we, I think, are coming to the conclusion that things have changed pretty significantly in terms of hydrothermal venting activity in this area. We're not seeing these bullseye mat features that were distributed in and among the clam beds in 2018, and that's not too surprising. These systems can be quite ephemeral with some of the hydrothermal plumbing changing over time and getting diverted elsewhere. So, but it does give us an opportunity maybe to try to find where we sat
Just on the other side.
a few years ago, the sub, so we can see the footprint of the sub, and we can do a heat flow measurement in that same spot, which will tell us maybe whether or not that has changed from the perspective of the temperature gradients in this area.
Yeah.
Yeah, I think they're back on the left.
Yeah.
They were right near those clams.
Yeah, if we're too far away from it, then it can't be the.
I think if this the old track here is I might even be right there.
Yeah.
Or we could, because that
I'll
kind of
turn
lateral
this off.
around
You
it.
can
Yeah, and where
I'll turn this
was
off and you can
the
kind of
slab
just
then?
The slab is on his flash.
Sure.
He's on a 1 meter scale.
All right, I'm going to turn this over to Sergio Parra, who's a graduate student in the geobiology program at Caltech, and he's going to maybe explain to some folks out there in Spanish some of the significance of the research that we're doing and what we're trying to accomplish with these dives here, and maybe a little bit about his research.
Hello, buenos días. Habla Sergio Parra desde el equipo científico a bordo de la nave investigatoria Falkor. Y pues como pueden ver, ahora estamos al fondo marino, en medio del sistema de ventilas hidrotermales llamada JaichMaa. Pues ahora mismo estamos tratando de encontrar el sitio donde empezamos nuestra investigación en este sistema hace ya 3 años, en el año 2018. Mirando el chat, hace rato creo que vi una pregunta de parte de José. José preguntaba que si había un sistema de cámaras infrarrojo para poder observar geografía o el relieve del fondo marino para analizar las temperaturas o para observarlas. Lamentablemente el infrarrojo, o sea, el agua es bastante opaca en el infrarrojo y no podemos ver el fondo. Pues tenemos que depender de lo que ve la cámara o las cámaras a bordo el ROV SuBastian para poder analizar y ver, o sea, el fondo marino. Creo que también tenemos otros instrumentos para el fondo, el sistema de sonar a bordo el Falkor. También tenemos de obtener temperaturas. Pues sí, esas son las herramientas que usamos para encontrar sitios donde haya ventilas. Que hay sistema ecológico, o sea, estas ventilas lo que hacen es que agua calentada desde bajo la tierra, de minerales, de iones que precipitan para formar estas ventilas que podemos ver. Claro que ahora mismo lo que se ve es sedimento porque estamos todavía buscando el sitio que encontramos hace ya 3 años, que también estos fluidos calientes que suben a la superficie están llenos de azufre. Son ciertas bacterias en alfombras que cubren el fondo marino. Estas alfombras son blancas, naranjas, lo cual nos indica que hay especies diferentes que toman ventaja del ambiente químico para sobrevivir. Hola José, qué bueno que todavía nos sigues. Aquí veo tu pregunta. O sea, no podemos usar instrumentos infrarrojos para, o sea, ya al fondo para observar las temperaturas, porque el agua es opaca al infrarrojo. Tendríamos que, o sea, solo se puede usar estos instrumentos cuando se observa cosas como la atmósfera, el aire, que es muy transparente al infrarrojo, pues a estas profundidades donde tendríamos que ver a través de metros de agua. El agua lo que hace es que absorbe la energía infrarroja para localizar estas fumarolas. Así que sí, no tenemos que depender de lo que ve la cámara y mismo tenemos también un instrumento que también puede observar temperaturas directamente. Un termistor que tiene bastantes termistores que metemos dentro del sedimento para ver cuán caliente, que hay una fumarola cerca, que hay fluidos hidrotermales subiendo por el sedimento. Ojalá eso pregunta, pero si no también puedo aclarar un poco más. Quizás también comentaré cuanto a nuestra capacidad para observar el fondo marino comparado a, por decir, la superficie de planetas como Marte, porque Marte tiene una atmósfera, casi no tiene atmósfera, bastante fácil usar otros instrumentos más comunes para obtener información no solo en cuanto a temperatura, pero composición mineralógica, relieve, claro, también. Todo esto es mucho más fácil usarse para observar la superficie de otros planetas, pero acá en el fondo marino, porque hay tanta agua entre nosotros y el fondo, el agua lo que hace es que absorbe las energías, frecuencias que usamos para hacer mapas de relieve, la orografía. Tenemos que ser un poco más creativos en cuanto a lo que podemos usar para cubrir lo que hay al fondo del mar. Por eso dice muy a menudo que nosotros sabemos más de la superficie de Marte que nuestro propio fondo marino. Desde la tecnología del sistema de los instrumentos a bordo de la nave investigatoria Falkor, también como el ROV SuBastian, nos deja a empezar a una mejor imagen de lo que hay en este planeta.
All right, so we struck out with finding our microbial mats, but we decided to sit down on the SuBastian footprint and take a heat flow measurement here. So that's going on in the background now. I think there's an inset maybe showing you the heat flow measurements. And our shore-based team will use this data and add it to the heat flow profiles that they were doing on Lake 2.
Okay, so heat flow 1. So this is before, so these aren't heat flows. This is before we start labeling. The heat flows one they did label, the next day we don't label. So Z. So Jared found where the marker was taken, and it was taken after we started labeling the heat flow 1, which is before we started quite some time. So maybe Lake 1, Lake 2.
Yeah, yeah.
So this was on Lake 2?
Yeah.
Yeah. Well, this will still be interesting to see how well we repeat a heat flow measurement in the same place. So it's still an interesting measurement.
There it is.
There's old clam tracks here.
Is that the shell? What's the guy's? Butterflies.
Oh,
Pelagic.
yeah. Pteropod.
Is that a pteropod shell?
I don't know. I do not know. We see some amphirettids in their little mud tubes. Suspension feeding. And that's an anemone.
Actually, it should be a pteropod shell because it should have dissolved.
It would be awfully big if it was.
Yeah.
I don't know what it is. Tumbleweed of marine snow. Okay.
It's tucked in between printers and I'm assuming that it's maybe what we'll do tonight is we'll flip it, we'll take that plate, turn it up so it sticks to the other printers. Yeah, I do. It's a little bit too low. I just assume I didn't ask much yet. Slide it a little bit, slide like that, and then bang it on the bottom. Then coming out of the bottom of the porch like this. Bang it on the bottom, just sit it on top of it.
This is where we sat down with the family.
Why would you sit
I don't know. Yeah,
and put a marker down?
I know.
Are we done with this, or?
We're within seconds of it.
What do you want me to do? I'm really good at driving in circles. Go back over to the other spot and set up.
I think we're gonna hit the other supers.
Okay, we're done. We can
Okay. Pull the pro.
You can wait for a while too. Just whatever. I'm available.
We can fly back over to our site.
Where were we this morning?
Yeah, look for another
Shimmering
type of
water.
guy. I saw a couple of
So do guys know where that is?
Which one are you going to?
It's where we were in the beginning. Yeah, over here. Yep.
That's crawled all the way out.
Rose out. So I haven't yet seen any real vibrant patches of clams here either. Did you guys actually see that, or was
No,
it-
they were dead. They were dead.
we didn't stop and look at them. Probably just the same time as we were. That looked familiar. Yeah. I would not do people, but I mean that was basically a time answer where you did okay, it's gotta be right there. It was just south of the block, so that was the matter. And it's dead.
Yeah.
So either
We'll go back where we were.
jump all the way up to say the transistors.
No, I think we need to get some tours.
Yeah, I think you're better off there.
Okay. All right. Turn around. Go back.
Am I going in?
You can go in.
Going in and setting us up there? Do you want to sit where you were before by those things?
Not
or-
exactly where, but we'll find a nice spot. Yeah, find a good spot.
John will stay with me.
Yeah.
And I don't know where we were. I got all turned around. You did so many loop-de-loops. Okay.
What's the plan?
Are we heading?
We're going back to the mountain and stuff.
I'll be
Yeah.
very fast.
And then we're
No worries.
Whoa, no. We're gonna do
Probing.
temperature
Probing.
probe. High temperature probe, followed by core.
Oh yeah.
And then we're gonna look for the familiar surface expressions. So we want to look for shimmering water, bright
Yep.
white mat, apparel vanilla, cocoa buds.
At the same spot.
Anywhere in that
anything,
general
yeah.
vicinity, anything that looks good. The most important thing is stuff that looks good and correlable, rather than any specific
A
location.
little gravelly. All right out. Maybe the hottest spots are gravelly though. Or if we punch a aluminum one further in,
Yeah.
might stand.
Yeah, it's hard because the gravelly, the
Interesting.
hot cores, when they expand coming up, flush out the tubes except for the gravelly bits. So
Yeah.
if
Right.
but the gravel
Where
without
is ROV?
mud is hard to collect.
It's true.
Updated waypoint for you.
So our map is
Updated
right in
waypoint.
here somewhere.
Thank you.
Yeah, I think so.
Yeah.
Okay.
So our block right there.
Mm-hmm.
Okay, so
Yeah.
that's where the map was.
Yeah.
I feel better that I couldn't find it on the first map.
Yeah.
So basically, right where we were this morning is the
Yes. Yes, please. Thank you.
teenagers, right?
Great. Thanks, Adam.
It's a lovely spot.
me see the notebook for a
Yeah,
second.
yeah.
Just want to get our coordinates.
I don't think I wrote them down. You can get them here.
Yeah.
Sir, will you scroll down to the bottom of the page? And yeah, yeah, or any of the HTs from earlier. Tell me.
Here we go. We're coming up on it.
No taking fail. See a latitude longitude? Or I'll just copy this one. If you click on it, it'll bring it up in the screen. I mean, we're pretty much at it.
Yeah.
We're about right there. Okay.
794. 620.
This is it.
Yeah.
Did we pokey poke in here? Like, we're gonna just get set up and look for the sites where we just orient. Okay.
Just tell me where you want to go.
I don't remember those though.
That
Yeah.
part.
So I think we're actually in the other one. So remember we left the original one, flew over another one, and we said, oh, it's kind of moundy. We might be folliculinids in it.
Yeah.
So I think this is actually the second site. So maybe we just keep going in this direction a little bit further.
Sure.
But this could be,
You mean, so you think our site is further south than this?
well,
Because we haven't been further south than
is this a bush core?
Yeah.
That's a bush core? No. I don't think this looks right because there were two bright white I drew it.
Yeah.
Two bright white patches of shimmering water. So I don't think this is it. But this is the second one, which could be good, but I don't see a lot of shimmering water.
Water's more to the northeast.
Okay, let's try that. Yeah, thanks. Yeah, so we'll just, just right there.
Yeah, just looking at the trail, but
Mhm.
if you look, there's only so much memory on this trail, so
Yeah.
it's actually disappearing as
Okay.
I follow. So
Yeah.
you very well could have been to the south here, but
Right.
it's
Okay.
disappearing.
I'm not showing anything to the south. You went east.
Yeah,
We went east, so we should go west.
this is where you were
This is where we were.
this morning. Like if you just look on my map here, that's where this one started here. So,
Yeah.
so just up in the left.
Well, I mean, it might serve us to go back to where we just were and take a few temperature
Yeah,
measurements.
that looked like a good spot.
Yeah, let's go back to where we just, yeah, I agree. We're gonna go back to the one we just flew over,
Okay.
just to poke around,
Okay.
just so there's data,
Yeah.
information when she comes back.
Great.
Okay, so we're gonna stop at. So there's actually at least two more mats that size that we haven't sampled yet. But these are much more rocky, like this is
Yeah.
not bode well. Stop at another mat.
Do you think if I land in this dirt, it will be
Yeah.
too hot?
No, yeah, right. That'll be fine.
The dirt should be fine.
Dirt's okay. So is the goal shimmering water though? Or I guess we could try one measurement and see. Fly
Yeah.
over holding it. The goal is hot. Hot. Okay. So it might be the original one. Do you want us to land out here? Sure. Let's just so we'll probably put a temp probe in the gray and the pink.
Okay.
Just to see.
Yeah.
If it's,
That'll do us.
if it's in the 20s, we'll go over there, yeah.
Temperatures
Since
and
we came so nicely over it. There's a. Oh yeah. Oh yeah, I forgot.
Pretty good shimmer from that.
Where do you
Black
see?
spot, the black spot in the white.
Oh,
It's
sure
shimmering over there.
enough. Sweet. Well, we might core it near there. So let's. What do you think, John? How about. What's that? It's like a little macaroon.
I think there's good shimmer out.
This looks really similar
Anyway,
to
you got some flow.
last 2018
Oh, it does? Okay. Go ahead and have a seat.
with the white, orange, and brown.
Yeah.
Okay.
Yeah, the mag
So the question is, Rebecca, where would we core? And there, that's where we should not temp probe.
Ideally, we could do both in the same vat.
The same color?
Yeah.
Well, here's the shimmering. So there's shimmering water for sure here. Z said maybe here. I'm not. Maybe. Oh yeah.
Yeah.
So, is the goal hot or all pink? Because pink runs through hot and into not hot.
Yeah, I think the goal is hot.
Mm-hmm.
Just that would be by the fluid flow.
Okay.
So it's like the one up to the top left looks like it's about the same.
So if we stuck up, well, we probably don't want to push core without her. All right, let's just So same thing she said. So Victoria. So we want to take a push core, but also leave some real estate. But we want to take a temperature probe measurement, but leave some real estate for a push core if it's great. Okay. So just a little bit below that shimmering water, or do you want? What do you think?
Point out where you want.
Yeah, what do you think? Just on the
gray
border,
and white?
border between gray and white in front here, and then we could always push core over there.
Yeah.
But not in the softest spot. Leave us the softest spot for the push cores, if you don't mind.
No problem. Yeah, here by the clamshell would be good because that's not.
we
a
would
great-
never
that's
core
not
over
a
there.
great
Okay,
core.
that's good call. Good call.
Perfect.
Do we wanna? Let's see. What is this? HT5? Oh, what's happening?
Do you want to do 5 centimeter increments?
Trusty, yeah.
Don't push the clam.
Okay. Let's try to avoid the clamshell. Yeah. There we go. Yeah. Yeah. Okay. That's perfect. Okay. Alright, 5 centimeters. 1846. This is HD5, 5 centimeters. Boundary between white, hot, and gray. Not so hot. It's weird. Do you want to abandon that? Just put it up there? Like, we don't need to do the whole series in this, you think?
Oh, we can do one more.
Okay.
It's going up.
Yeah, it's still going up.
I think we're just gonna put the hole right there. I think one side of the probe's probably.
Oh.
Okay.
That's probably not gonna be great.
Okay. We could just one. Yeah. Well, we want to hug the rim of this white, shimmering water. The mat
We can just do
in the shimmering water.
Yeah.
And then you don't care what's out here.
Well, we can test to see like how hot it is.
Okay. Let's go right in the shimmering water, says the team orphan. Okay, so that was 21 surge, I think. 22. 23, okay.
Yep, just a little.
HT6 in shimmering water.
There we go.
5 centimeters.
That's now we're talking.
Now this is acceptable. What's going on there though? It's an illusion. What's this? What is it? Did that come?
It's hot.
It's hot. Okay. Yeah. Let's just see. Might let it flow. Yeah. So push core behind, or take a temperature probe. So this looks maybe coreable. I don't know.
Still at the top.
Yeah, I know. If you had to choose where you wanna,
To the right of the control.
yeah, like push core or take temperature first. You have to do a temperature series, right? And then you disrupt.
So if we did a temperature there and then go behind it for the core, is that too far away?
I think we're pretty close, actually. Let's see, where's the down cam? I think they can reach it. Okay, let's go with 80. Okay, Jared, can you just come to the right, just into the gray?
And probe there?
Yep.
Okay.
How far do we have to be away that didn't disrupt this? I think.
We're only going down 5 centimeters. It's much less
Okay.
disruptive. You can pass the bend.
A little bit more. Kind of where my little stick is. Yep, that's perfect. Okay, let's see.
It's when you get past 10 centimeters.
Then the
disrupts
flow
things.
down below. Okay. HD7 surge?
Yep.
Okay.
Did you say you wanted me to go 10 centimeters this time? I'm sorry.
No.
Okay.
This is good. Just saying that it, in terms of disruption, going past 10 centimeters causes
Looks
more
like trash.
disruption because of the bend. Yeah.
Doesn't that look like trash?
Yeah.
In the vent?
Why?
Why? Humans. That's why.
Just get it out of the clamshell. No.
We could take it. It might disintegrate. Later. A little crunch for time now. So it's only 16 right here.
Yeah.
7? I'll go 17.
Yep.
10 centimeters, please. I mean, maybe you just have to get like right on the focus. Right on.
And
Get
then
right on
deep,
the edge.
deep.
Oh, here comes the trash. Let's film the trash. As a reminder.
Maybe there'll be a name on it.
Yeah. Like sheet of plastic. Is this a problem though? If we have a hole this big,
treasure
or
map, like
that
all
always
the-
helps?
It's a treasure map.
Invisible treasure map.
Mm-hmm.
It's only 26.
Yeah, I
I
think
think it's a big hole.
Yeah.
Right here. I mean, we could push core there. No, too close.
I don't want to poke.
What if we
28 surge.
Got it.
What if we did a push core in the white mat with the cope pods, and then left it there?
Yeah. Aluminum.
Aluminum
Okay.
core.
Yeah.
Stuck the probe in right next to it.
Yeah.
Okay.
While the core is still in.
Fun.
Like aluminum?
Yeah.
Yeah.
Okay, let's do that.
Because I think right around the
We think it's really focused.
Not over the focused flow because that's going to be disturbed, but as close as you can get to focused flow in the white mat without being right over it, I think that's going to be the hottest.
Let me get this probe out.
But if we try to measure it, it's just going to destroy things.
Yeah.
It's too small.
Okay.
30.
It hit 30? Okay.
Clear to bring the probe out?
Yeah. This bend in that probe is a problem. You gonna stow it normally? Okay.
Yeah.
You should be able to reach downward or to the core. That's what he's saying.
Coming in the middle. Yeah. I mean, only if you could really like stick it in the ground, nozzle in, and not lay it on the. Yeah.
They could stick it in. Yeah.
It's true. Bam. It's true.
What's that?